This is reserve problem number 9 from chapter 6. We will do a test of hypothesis for a population proportion. Quality manager at Bestiful Company is certifying a new process that must produce at least 95% good products before the process is considered proven. A sample of 40 containers from the process line are tested, and they're found to be 93% good. So we must formulate a hypothesis, test it at the 0.01 significance level, and report what the results are. So just a quick review of what a hypothesis test is, or how to perform a hypothesis test. So when you're doing a hypothesis test, you have a research question that you're trying to evaluate. We call that the alternative hypothesis. Sometimes it's called H sub 1, or sometimes it's called H sub A. But anyways, the alternative hypothesis is what the researcher is really testing for. There's some question that he believes may be true and he wants to test it. In this case, it's pi, or the population proportion, is greater than 0.95. But the opposite of it is going to be stated as the null hypothesis. So the opposite of greater than would be what? Pi is less than or equal to 0.95. The null hypothesis in hypothesis testing always should have an equality attached to it. So it's either for a two-tailed test, it'll have an equal sign. And when you're doing a one-tailed test, like we're doing now, it will always have the equality attached to it, so less than or equal to. Now, this is what the researcher really wants to know, but the opposite is what he's testing for. So the null is always what is being tested. But in doing so, we make it very difficult to reject the null. And how we do that is by setting our alpha level to be really low, because alpha is the probability of rejecting the null hypothesis. So when it's true, rejecting a true null hypothesis. So make it difficult to reject the null. Okay? How? By setting our alpha level to be 0.01 in this case. Generally, alpha level or significance of the test is set to be at 0.05 or lower. So only a 5% chance that the null hypothesis is really true, but we end up rejecting it anyway. So in this case, we are setting it to be 0.01. So let's go ahead and draw the diagram for it. If this is the curve representing the null hypothesis, this area right here is going to be the rejection region for the null, which is for null. Rejection region for the null, which is 0.01. So over here in this white area, cannot reject null. Okay, so we do this and we set our significance level first, and then we test for the hypothesis. Now, in this case, because we have a sample size of 40, we use the z-test because that's more than 30, count more than 30. And there's, for a one proportion test, the test statistic is computed like this. The proportion from the sample, lowercase p, minus the hypothesized null, divided by square root of the hypothesized null times 1 minus the hypothesized null, divided by n, which is the sample size. So in this case, we have proportion was 93% that he found from the sample. minus the hypothesized null, which is 0.95, divided by square root of 0.95 times 0.05, which is 1 minus 0.95, divided by 40. This will be negative 0.58 when you crank it out. So we know that our computed or the observed test statistic is a negative 0.58 over here because the middle is 0. Now let's go ahead and test for this point. We're going to test for we're going to find this number right here to see what that cutoff is for the rejection region. Okay, and that number I can compute using the inverse of standard normal. So that I'm going to set it equal to norm dot s dot inverse, and I'm going to test it. Compute it for 0.99 because we know that this area to the left of it has to be 0.99 because the rejection region for the null is 0.01. Okay, so this number we found to be 2.33. Because our test statistic, meaning what we observed from the sample, is a number that falls within the rejection region, and it doesn't fall within the rejection region because it falls in the area where we cannot reject the null, then we cannot reject the null. So we agree that the population proportion is in fact less than 0.95. So he cannot claim that the new process is producing 95% or better good products. Therefore, we fail to prove his point, and there is not enough statistically significant evidence for him to say that his process is making 95% or better good products. Thank you.